Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Fred Schenkberg. Hey, Carl.
Hey, Fred. I get regular questions on FMEA. It's part of the joy of my life is seeing these really interesting questions that come in. And there's a series of questions that have come in recently on FMEA Occurrence. And I thought that might make an interesting podcast topic. What do you think?
Yeah, no, that works good. And I'm sure you've already provided the people that ask the questions an answer and stuff. But as I warn people at the end of every episode is that, send us your questions. We'll get you an answer. And it'll probably get expanded on in some podcast coming up. So we always are looking for these questions. And like you, it's not like we're talking into a microphone in a place where it's quiet, and so we don't see the audience. So hearing from you in any form is great. So a little plug for that right at the start. But Occurrence, I've seen that used in all kinds of different ways, and some of them I kind of go, I am not sure about. So what was the nature of that question you were?
Yeah, the nature of it had to do with the concept of occurrence. What's it used for? It was a person fairly new to FMEA, mm-hmm. and so basically I turned around and linked my article on FMEA Occurrence and sent them more information about it. But it was an opportunity to share some of the big issues about it. So let me just tell you what comes to mind there. Because occurrence gets misused a lot in FMEA. For example, there are applications that take the occurrence ranking, even if it's subjective, which it usually is during mm-hmm. product development. And that's a topic I'll get to in a minute, but a subjective occurrence ranking, and they basically assign failure rates to it, and then they create a reliability model from it. So there's software and applications that take the FMEA and take the logic of the FMEA and then create from it the beginnings of a system reliability model using the occurrence ranking as a failure rate and then creating the reliability numbers from it. And I have a lot of problem with that. So I made sure that my answer, I can see your reaction right away.
Yeah, no, just because you can do it doesn't mean it's useful.
Yes. Well, and plus, I think there must be some law, that in the universe, which is if it's easy to do, it'll be done. In other words, if you assume an exponential distribution, then you can take the occurrence rank and you can create reliability numbers really easily, and therefore it gets done a lot because it's so easy to do, and it happens to be wrong in most cases. But one of the answers back, because I did like a summary of 3 paragraphs. One of them was on the objective of the FMEA, which is really, if it's a design FMEA, it should be to improve the design or improve the tests. Right. And that should be the objective. And therefore, the occurrence ranking is one of the ratings that, along with severity and sometimes detection, that helps you prioritize issues so that you can improve the design.
Right.
It's not an end result in itself. So that was one of the topics I brought up with the gentleman. Another one is, do you do the occurrence from the failure mode or the cause? And I do it from the cause, and most standards now have come around to that because causes can take you in different directions, and we want to know which of those causes is the big hitter or the biggest hitters so you can address those.
You can deal with causes. I don't think I've ever seen or recommend anybody do it on the failure modes, the symptoms that you see directly. That's the kind of your lead in. Here's some function that's not working, and we get this kind of behavior, and it's important or not important, dependent on severity. Yet it's always been intuitive to me anyway, that there's multiple causes for any of these symptoms that you get, any of these modes, failures, things that you recognize on the outside. But those are the things, more importantly, is those are the causes are things I define those as those are the things you can deal with. You can design out, or you can mitigate, or you can, detect, or do all kinds of other things to improve the design. Whereas the failure mode, you're shooting in the dark unless you know the causes.
Precisely right, Fred. And that's exactly why you want to assign the occurrence to the cause so you can help prioritize. And you've said it really well, which is the cause is what you can address.
Right.
And if you get, because cause is really like in a design FMEA, it's a potential design deficiency. And if you also include the mechanism of failure, then you can do amazing things in the recommended actions to fix the problem,
right?
Especially if you've got the root cause. So that was the second paragraph, had to do with, do you assign the occurrence to the failure mode or cause? And then the third part of it is, how do you, if we got all that in place, then how do you assess the occurrence ranking? And so I instructed the person to use 3 techniques, 3 inputs. One is field data, or if you're doing a process FMEA like manufacturing data, that's input. But
there's a caveat on that one, though.
Yes,
Carl,
exactly.
you has to be down to the cause. If it's just that screen's blank, well, then that's the mode. That kind of bounds where you go, but there's multiple causes for that. So it's got to be reasonable data.
It really does, and therein lies the rub on so much of this, is because field data often is more of an accounting for warranty reimbursement or for some type of tracking, as opposed to root cause.
Yep.
And so you have to take that into account. So that's why I always say it's an input. The other caveat, in addition to what you said there, is that usually the design has changed or there's new technology. Otherwise, you wouldn't be doing an FMEA.
Right.
And the fact that it's got new technology, new application, new environment, that changes how you consider or how you use the field data, because that failure mode may or may not be present in the new design, or it may not be present in the same failure rate.
Right.
So it's all input, that whole subject of field data.
Well, at that point, it starts to become subjective pretty quick.
Exactly. And then the second contribution is, in the FMEA world, we have a column called prevention controls, design controls prevention, or process controls prevention if it's a PFMEA. And those are the methods or actions that are currently in place to address the cause. And so the team has to consider that, because if you've got really good methods in place on this particular product, then as part of your product development, then the occurrence ranking is going to be lower than if you have really lousy prevention techniques in place.
Yeah. See, I usually put that as a double line, is because the prevention stuff I often see is we test, sort at the end of the production line kind of thing, or, we do ongoing reliability test, or we do this or that or the other thing. And sometimes there's filtering out and reworking a significant proportion of their products, and that gets expensive. Yeah, it might be effective for them at an expense. So I say, well, if we take that away, what's the occurrence ranking? Oh, now this is a top hitter for us. It happens all the time. Well, how about we look at what we can do to design that out and avoid the cost of the sorting and prevention stuff you do later?
Excellent. Yeah, very, very good points, because then those will become recommended actions in the FMEA.
Right.
And so that kind of dialogue is really, really good. The third input is how much of the design is new, like new technology, new applications, new environments, because that inherently adds risk, and so you have to take that into account. So if you're taking into account those 3 things, then you can sort of balance what the occurrence ranking will be. Go ahead.
Well, I almost never have data with these things, but I have run into people that try to shove data into it. They take vendor fit rates, or they open up Mail Handbook 217 and they fill it out that way. And I saw one of them like that. And I suspected they were doing that so they had a hard number in there that then the software could go create a model for them. I'm like, no, Don't do that.
Yeah.
For all kinds of reasons, but don't do that. But it's when you're in a room and somebody says, correct me if I'm wrong, but I have new technology and we really don't have experience, or it's kind of like stuff we've used before, but we don't really know. And we're not really sure what's inside this little box that we're getting. I look at the occurrence rating at that point is it's fuzzy or just unknown. And I tend to say, well, how bad could it be? And we don't know. What's the upper range of that? And then it might be on a 10-point scale, it might be 7 or 8 or 9 or whatever. It's just unknown. And I find that capturing what we don't know in these ratings, and not just occurrence, but any of them, is a signal then for those action items that go say, well, we need not only to address this as a design issue, maybe, but we need to understand what's the risk here? How often will this likely occur? So as we build 100 prototypes, if every single one of those prototypes shows this particular cause, well, then, yeah, we probably really need to deal with that. But if none of them do, well, is that enough evidence that we don't need to deal with it? Let's think about this, guys. But it's not a failure rate. It's not the end goal. I look at it for occurrence. One of them is, well, what do we know and don't know? How well do we understand this? If we got great field data and it's a slightly new application, but the combined knowledge of our engineering talent and experience is going, well, this is a low problem. It's unlikely to occur for us, and we're pretty certain of that. We give it a lower number. But if it's unknown, give it a higher number. And or it's, we're taking a risk here going to this technology, and we know that it has a higher than we expect failure rate. This cause, we're putting it in a saltwater environment now. We got to deal with that. We know it's going to be higher. Then you give it a higher number. It's not like, oh, it's 8.7 fit rate here, and it's a Weibull curve with this characteristic life over here. No, it's relative ranking of this is from our experience and all those inputs you talked about, this won't happen very often, like once a year in all of our production. And this other one will happen every time we turn the product on. You got to rank it. You just got to force rank it into it. Because I've also seen the occurrence rating where they go, everything is a 2 because the table we're using says anything between X and Y, which is a broad range, usually an order of magnitude type range. Well, everything we do is in that range. So everything's a 2. And I'm like, well, that's also not helpful.
Well, yeah, exactly, Fred. So I'm agreeing with a lot of what you say. I have a few thoughts about it. First of all, just to comment on the everything's a 2. I've seen those type of FMEAs, and they talk themselves into it, and it becomes a really simple answer, but it doesn't add value.
Right.
Because the whole point of the risk ratings, like severity, occurrence, detection, if you use detection, is to differentiate, to prioritize. And that's the whole point of it. It's been that way for decades. And the people that think they can extract a failure rate number, like you say, 8.57 out of that, or 0.0, whatever, that violates the reality of the validity of your input data. It kind of goes along that conversation we had before we hit the record button on assumptions.
Yeah.
You're assuming that you can extract a failure rate number out of subjective information. And that is often a wrong assumption. Yeah. So let me just make a few comments from what you said. First of all, and I know you weren't saying it's always 1 to 10, but I'm starting to align more to 1 to 5 scales. Mm-hmm. And I would state that we want to get the minimum number of gradations that are needed to differentiate the risk, because oftentimes 1 to 10 adds more confusion because you don't need 10 gradations. And so I'm more often than not now moving towards 1 to 5 as gradations rather than 1 to 10. Yeah. And I know automotive has been a 1 to 10 forever.
Well, I find I'm very flexible about whatever ranking is. And sometimes you find out that you start with a 1 to 10 because somebody said, well, that's the training we all got was based on that kind of scale. Here's our starting point. But then I find out that it's like, well, that's in the 1 to 2 range, or that's in a 2 to 3, 3 to 4 range, or that's in a 9 to 10 range. And it ends up being a 5-point scale anyway, except when we get a whole pile of them in 7/8s. And I'm like, all right. And so they're not all 8s. Which of these are lesser 8s? And let's make them 7s.
Yeah. Well, and you're a good facilitator, so you're going to be able to navigate that. Whatever the scale is, you're going to get to the place that adds value.
Yeah, I should mention that if we want to do everything as a 2, all right, let's add a decimal to that. And most engineers can deal with that. All right, it's a 2.1 or 2.7.
Yeah, the whole idea is to prioritize. The other comment is a new technology. Now, if you're doing a lot of startup work or companies that are dealing with lots of new technology, then it's going to be subjective.
Yeah.
And even if it's subjective, I still want to get the right people in the room. So I want to have subject matter experts that really understand their stuff. And then I want to ask them, how worried are you about this?
Yeah.
Have you ever, rarely is it so new that they've never done anything like it, or they haven't even seen anything like it.
Right.
And so I want to get a sense for how worried they are about it, and then use that to help put it on the scale somewhere.
Well, that reminds me. I mean, it's not much reminding. I did this yesterday with a client, and it was fun. They sent me a prototype. I got to play with it a bit, and I'm going to take it apart, which is my next step. But they got me on the phone yesterday with one of their engineers that was kind of doing the CAD flyby, which is just magic to me. Is, well, we don't need to see that. We need to look at this. Let's rotate that. And it's all these colors and wires and tubes and everything going around. And it's fascinating going through a CAD drawing when somebody really knows what they're doing with it. And it was, well, wait a second. How many of those do you have in here? What's that orientation? How long is that throw for that weight you're suspending there? What about, and we were on the phone for 3 hours, and they were just taking notes left, right, and center. And it reminded me a lot of an FMEA where, somebody knowledgeable with the technologies involved just takes another look at it. So it was quasi review process, but it was just walking through and a lot of questions of like, well, what about this area? What keeps you up at night at this? What concerns you about that? And then they would ask me that question and say, here's the, theory of operation of this thing. Here's our drawing of it. What do you think? And he says,
that's great.
And we went back, and it wasn't trying to, and it was really aimed at increasing awareness of where to go look. And it may feed into an FMEA at some point or another, but they were going, didn't think of that. We need to go figure it out if that's going to be a problem or not.
Very high level FMEA.
Yeah.
What keeps you up at night is a great question. I mean, that's essentially what's the failure mode is usually expressed in that way, or it could be an effect.
Yep.
Let me just summarize then. So the answer back to this reader, field data, you can use it as input. If you have data, that's great. But the main thing is to understand the limitations. And so, like you pointed out, the data may not get to root cause and often doesn't, or the data may not be relevant if the design has changed. Mm-hmm. And so field data is one thing as an input, but be careful about it. The second is what controls do you have in place today? And like you mentioned, they may be good controls or bad controls, or they may be controls that can be improved. But you want to understand what they are at least, because that'll help to inform occurrence, but also, as you pointed out, will help to inform recommended actions. And the third is to have a really good understanding, and this is, of course, by having the right team, how much new technology there is, new applications, and of course, don't forget new environments, because that'll affect the occurrence. And remember, it can be subjective, and it often is, and it usually is in a design FMEA, because you're making changes to your previous designs. And so it's going to be a subjective in nature, but it's all for the purpose of risk prioritizing. So that kind of summarized my answer to the reader on the subject. And I thought that might be interesting to share with listeners.
Yeah. Now, I would add one more point to your 3 is that remember the purpose of these ratings and rankings is to separate them. It's not to find the absolute number. It's really not. It's to think of it more of a forced ranking of how often is this cause likely to occur. And So it's not to provide 8.37 whatever units you want. It really is not that point. And I've seen teams get so wrapped around the axle around trying to get the absolute number, and they go off doing all this research to find a fit rate for a small LED. And I'm like,
and
really?
they make assumptions to be able to use calculations and shape parameters and what have you.
Yeah, and they spend hours doing that, and I'm like, this is something we're never going to look at again. It's such a low risk, and even if it does fail, it's not a big deal. It's like, move on. Don't worry about that. But yeah, so anyway, no, I'm glad you got the question. It's always fun to dive in on those things. I like bouncing the, techniques we each use to do these things to see if I'm off in left field, which I usually am.
Oh, no. Love to hear from people about this. How do you do occurrence ranking? What do you run into? And what else do you want to know about it?
That's right. And let us know over at accendoreliability.com/go/SOR. And Carl and I and the other hosts of the show are available through LinkedIn and through our About pages, and even on the articles and podcast episodes in the comments field. I often forget about that one. And I think that's where you're getting some of these questions.
Absolutely.
And I think you cheat a little bit. You have this ask Carl a question kind of thing, ask me anything kind of thing.
I do.
Yeah. But all good. Thanks for the question. And thanks, Carl, for bringing it over. And we got the chance to expand on that a bit. That's great.
All right. See you later, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.